Okay.
What the?
So basically, you want to go backwards from n to 0, and you want to, whenever you see a positive number, you know the previous few days, you know what the value should be. So if you come across a 4, you know the previous value should be 3. Nice. The one before that should be 2. One before that should be 1. And in this case, to make it easy, for the ones that we know for sure are breakouts, I'm going to set them equal to 0. So -1 means you don't know if it's a breakout or not, and 0 means you know for sure that it's a breakout. So basically, before I start typing, to print the final answer, what you do is just loop through. The minimum will be the number of zeros, the ones that you know for sure are breakouts, and the maximum will be the number of zeros plus the number of -1s. Because if you're assuming every single -1 is a breakout, like the values that you don't know for sure, you assume is a breakout, that'll give you the maximum, right? So maximum is number of zeros plus number of -1s. Minimum is number of zeros. So here I have the input. Basically, you just input the value into the array, and then immediately I just check if the first value isn't 0, or if the first value is positive, like the first day is not a breakout, then obviously it's impossible. And after that, I just set the value of the first day equal to 0, because you know the first day has to be a breakout, right? Okay. And then now, huh? Oh, I don't know. I just like adding an extra letter, because sometimes if you use like max, if you do 2 x's, it won't be an error. With 1, it might call some kind of function. So I just do that just to be safe. Alright, so now the loop, it starts from the end, which is n minus 1, I is greater than 0, and I plus plus, or minus minus. So you just go down, right? And you just check if the value in the log at I is greater than 0, then you have to loop through the previous few days, right? That's one case. Otherwise, if it's equal to 0, then in that case, you actually don't need to do anything if it's equal to 0.
Shouldn't it be if log I is less than 0?
If it's less than 0, it's always -1. So the ways we solve this problem is that if it's greater than 0, let's say it's 4, we know the previous one's 3, the previous one's 2, the one before that's 1, the one before that's 0. But if it's negative, then we don't know what it is. Alright. So actually in this case, we don't even need to check for zeros or -1s yet, because we just have another loop that checks that after. I'll do that later. Okay. So for now, we just say if it's greater than 0, then we go through the previous few values and we set those equal to the proper values. So for int j equals I minus 1, I, okay. J is greater than I minus log I, or greater than equal to, and then j minus minus. So you just, I can't really see it sideways, but yeah. So that way you go from the current position and you go left whatever it says in the log in that position is. So if you're at position 10 and then log says 5, then you go left 5, right? And you just set that value equal to whatever it's supposed to be. Log j equals I minus j. Wait, equals to, equal to, wait, it's equal to log I minus minus I minus j. Does that make sense?
Why did you just have it like if log 0 is greater than 0, you just print -1.
If what's greater than 0?
Log 0 greater than 0.
Oh, because if the first day is not a -1 or a 0, then you know that it's impossible. Because if the first day it says 1, that means there was no breakout that day, which is not possible.
Wait, that would just mean that the input date that they give you is...
Yeah, so if the input they give you is impossible, you're supposed to print out -1. So I guess you don't have to have this, but sometimes they might be a bit troll and they just put a case where the first value is wrong. So I just put that there just in case, just for the sake of accuracy.
I don't think I accomplished that.
Yeah, you don't have to. I just did it just to be safe.
But how would you know if it's impossible?
Oh yeah, I'll get to that. So right now we're setting the value. So Does this line make sense? It might be kind of confusing. So I minus j is how far you are from the position you want to go left from. Right? So let's say you're at position 10, you see a 5. Right? That means I equals 10 because you're at position 10. And then j goes from 10 to 5 because you want to go left 5 spaces or 6 spaces. 5 spaces.
So you have you have 3 loops, you have a
2
loop
loops.
inside a loop.
Yeah.
Inside a loop.
Oh no, I have a loop inside of a loop, just a double loop.
So USACO doesn't have enough test cases to test like if you actually.
They do, but they just don't because they decided not to. They don't always. They actually don't always do the hardest possible test case.
Oh.
They just do like near the hardest. Yeah. Okay. So in this case,
Cover that.
so this means that when j equals I, log of j equals log of I, which doesn't really do anything actually. But so when j equals I minus 1, log of j equals log of I minus 1. When j equals I minus 2, log of j equals log of I minus 2. So that's how you set the values all the way until log of j is equal to 0. Does that make sense? So it basically just sets all the values. And now after this loop, you've basically set all the numbers that you know for sure. So that means right now, after you run this loop, if the value is -1, it could be a breakout or it could not be a breakout. And you've basically considered every single day that you know for certain whether there's a breakout or there's not a breakout, right? So after that, you just have a int. Wait, why is there a bracket there? Oh, okay, whatever. You have an int min equals 0, max equals 0, and therefore you just loop through. You loop through the log, right? And if it's 0, right, then you increase both the minimum and the maximum because you know for sure that there's a breakout that day. Otherwise, oh wait. And then if the value is equal to -1, then you only add that to the maximum. Because it doesn't have to be a breakout, but if you want the maximum, you assume it's a breakout, right? So just add it to the maximum only, and then after that, you just print out the minimum plus a space plus max. Alright. Does that make sense? I think this is probably the most confusing part, where you just go to the previous days and assign the values to the original value -1 and the -2, -3. Okay, and then now we want to check for the impossible case, right? So when is it impossible? It's when the thing you know for certain isn't what's in the array. So like if you know for certain something in position 5 is supposed to be 3, but in the input they give you sets that value to like 10, then you know it's impossible because it has to be 3. And the reason this works is that every position that you go over, you know for certain what that value is. So if it's different from what you expect it to be, it's impossible. So all you have to do is just, so this is the value you think it's going to be. That's what you expect it to be, right? So you just say if log of j is not equal to -1, because if it's -1, it doesn't matter. You're just going to reset it, right? If it's not equal to -1 and log of j is not equal to what it's supposed to be, which is this, right? Then you print out -1, -1, and then you return 0. Right? Does that make sense? I think this part is probably the hardest to understand because, so basically if j is 1 less than I, log of j is log of I minus 1. If j is 2 less than I, then I minus j equals 2, right? So log of j equals log of I minus 2. If j is 3 less than I minus j is 3, and then log of j is log of I minus 3. And then you go all the way down until j equals I minus log of I, or yeah, I minus the number in that position, and the final position should be equal to 0, and in that case it will be equal to 0.
What is I minus j?
This is how far you are away, how far away you are from I. So if you're 1 away from I, the value should be 1 less than the value in I, right? Okay. So this loop just puts in the values you know are there for sure, and then this loop goes through to find the min and maximum. And yeah, just print that out.
Can I